Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Nwaka. I am your instructor. Okay, this week we have got two new projects which we are working on, and these are live projects. And we, as you all know, as our culture right here on Ekidel, almost all our videos are all live projects. So all the buildings that we are using to design to show you guys how to use Protastructure are live projects. And this week we have got two more live projects which we are trying to work on for a client right here on Ekidel office. So looking at this right now, you can see that this is a residential building of which it's a small building actually having a ground floor and also a first floor which contains of these rooms up and also a living room and also down floor also. And also the next project which we are about to work on, which will be once we are done with this one, is also you can see a complete plan right here. This is a classroom block and see this is a classroom block. As you can see that this is a full classroom block project which we are about to work on. And also if you look at this classroom block and see this right here, it also have all the sections available for us to perform our design very perfectly. So I'll say that we will begin this other classroom block design immediately after we have finished this Mr. Caleb's building. So for this week, which is the third week of August, I'll be showing you how to design this residential building. And this will not be like other type of videos which you have seen, because right now we have all our complete tool to perform a full structural design and detailing, because we have already shown you guys what they call stone bridge template, which is used for detailing. So since this building is a small one, so this building will comprise of, first of all, we will have to perform our GA drawing on this, and then we have to now design for this structure. Then we will now use a stone bridge detailing template to now perform the full stone bridge structural detailing for this structure, which will use that template to perform the detailing for this structure. And also we will put them all in, because we have been having comments most of the people that they don't understand how to use that stone bridge component template. So after we have finished the design of this structure for this residential building, we will now use that template now to start to now detail this structure. Also, for next week, there will be a software coming up for staircase design and detailing. Although Stonebridge Company is still working on the software, but um, from the info we got last week that they are almost done with the software for the staircase detailing. As you know, we don't have enough software that can design a staircase and also produce the structural detailing for you guys. So lucky for Stonebridge, and that we have Stonebridge Company, they are almost done with their own softwares. And as you know, Stonebridge softwares or Stonebridge 2 is always perfect for us structural and civil engineers. Okay, so right now, the first thing to do right now, once we got this plan right now, is, as you know, our culture, we always copy it out, because right now we want to perform a GA drawing, what they call GA drawing. And if you're a follower of Ekidel, you know that my name is Justice Nwaka, and the way I used to teach is that I used to teach in a very basic way for so that everyone can simply understand. So once you get your plan drawing, either from your client or from the design architects, as a civil or a structural engineer, the first thing to do is to copy out that drawing, because you don't have to work on that particular drawing. So copy it out in case there is any issue. You have a reference point to follow. So right now, once I copy it out right now, I'll just right now just create a block just like this, so that I would have to now know that this is the copied file, and this is the, let me say, original one. So right now I begin to work on this particular one right now. So knowing our culture right here, we always remove all the dimension lines, because we don't work on this. So to begin our GA drawing first, we have to remove all dimension line. And to make this very fast, I'll just use enter, and then I'll just click on them. I can use click on this and right click and say similar, as you can see it here. I'll use similar, I'll just click on similar, and it will select all the similar dimensions, which it is here. So I'll hold shift and select this, because this is our main original one. So this will only remain. I'll not use and select enter, and that will go off dimension line. So right now you can see what we have, that our plan is all clear. So right now, if you check this right now, this is having like a block symbol because this plan was drawn using what they call ArchiCAD. So when you have your drawing done by what they call ArchiCAD software, and you are trying to export this drawing into Protastructure after placing your column points and also paneling your structure, you have to first of all explode this structure. So any plan that comes with with what they call ArchiCAD software into AutoCAD, first of all, before product structure might we will accept that, you have to explode that structure at least twice. So right now, I'll select the whole structure for this right now, not this one, but this one that I've copied, and explode it first one, and also do the same thing again and explode again second time. So it is by this that when you export this to product structure will be able to read all these lines as a drawing line. Else, if you export it just like this, how the showing block as you can see it here, it's like it's as if it's a block line. It not be able to show inputter structure. It will just show blank. So you have to explode it to get this kind of thing where you have a single unit. You can see there a single unit. You can see what's happening right now. So explode it first to have a single unit. So right now you all know that we don't used to follow the grid lines done by the what they call architects. We also use our own grid lines. So I would first of all delete all their grid lines to create my own structural grid line. So that as a civil and structural engineer, you have to create your own structural grid line, but at least it should be in conformity with also the 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 plan, so that you don't have to go and change the plan. So I'll first of all remove all these structural grid line to create my own grid line myself, because that is the gain for you to be like a civil engineer. So right now I have to perform my GA drawing. What they mean GA drawing simply means general arrangement drawing, which means to place your column and your grid. So for you to export, for you if you want to export your plan from AutoCAD to Protastructure, there are two layers which you are meant to create. Without that two layer, Protastructure will not be able to see this drawing and also see the column point as column, or the grid line as axis. So right now you have to go to this layer right now, click on this layer properties right now, and allow dialog box to appear just here, as you can see it here. Now, once it appears right now, you have to now click on this place to create new. So once you create new, it will show like this, and you have to call this call this one grid line, call this grid line, and then you also call, then go. I always like to change color. I need to use my color for grid line. Let me just use blue. Let me use blue. Okay, or let me just use this magenta. Let me use yellow. Okay, yellow is okay for me, and I'll click on okay, and then I'll leave all here as default. I can use this place if I want to use let me say use dash. That's if you want, but the main thing is to have this thing called grid line, and then I'll go again and create a second one again, and I'll call it column. So this is the two grid lines that what they call Protastructure need from you. So I'll go here again and choose my color to green. You can choose any other color if you want to choose, but I like to use green. Okay, I'll choose this green. Now I'll go here and choose my line type as continuous, and I'll say okay, and then go to this line width, and I'll choose here as 0.30, or I'll just use 0.50, and I'll click on OK. So this is the two layers you're meant to create, grid line and column. And I'll click on, and then you go right now and then just close this right here right now. So right now you now go to this place right now. We want to first of all create our structural grid lines or axis or layer, or yeah, axis. So I'll go here right now and activate what they call grid line. Now, once it shows grid line right now, to create my grid line right now, I will use what they call a construction line. So I'll just type XL, which means construction line, and I'll click on what enter. Now click on V, which is vertical, and click on what enter. So I want to create my vertical grid line first. So if I try to place to find a center for this right now, I can see that this is my center. To now verify that this is center, I'll just go right here and dimension it to check if the center, and try to zoom it out. This wall is this wall thickness is 225 wall, which is 9 inches. If you're using inches, you can see it here. So my center line, my half of this wall should be 112.5. You can see that. Okay, so that means that this grid line is at the center. So right now, I'll also go again right now, copy this one right now, and begin to place at the center of every wall. So I'll just use this place as reference point, these outer ones here. I'll begin to click at the outer point here, an outer point here. Else, if you don't want to use this method, you can also go this way also by creating, first of all, creating a division line here first using L, and then use XL, enter, vertical, enter, and place the vertical line here. So whichever one that then now take off this right now. So whichever one that will be easy for you to do is also okay for you. So I'll just copy this right now and begin to pick this point, as you can see it here, and use a reference point. The whole idea is to create this axis, this grid line to be at the center of every wall. So that's the whole idea. So anyone you can use to make it to get this grid line at the center of this wall is okay. So you can see what I've done right now. So right now again, I'll go and click also create this here. So I'll create my grid lines at the center of every wall which I want to insert my columns or I want my beams to run. So right now I've placed this right now. Meanwhile, I am doing my general element drawing on my ground floor plan, not at the first floor plan. So always do it at the ground floor plan. So right now again, I'll go again right now and do XL. Now, since I've done placing all my vertical grid lines, I'll now go to go and create my what they call this horizontal grid line right now. So I have to create my grid lines for also these horizontal walls. So I'll do XL right now, enter. Now, instead of typing I'll type H. H is for horizontal, and I click on what enter. And I'll go and locate the center of this wall and then try to now you can see that we can find center here right now. So I have to create a line first to show my center here. I'll now do XL, enter, horizontal, enter, which is H, and then find center and put it here right now, and then delete this immediately right now. So you can see that we now have a vertical grid line and also horizontal grid line right now. So I'll copy the horizontal one right now and begin to place at all the horizontal walls. So I'll copy this right now and come here right now and place this here, and come here again and place this here also. Okay, so right now I now have this place right now as my horizontal. I don't want to place it here because I want to use here as a full panel. So right now let me take this off, or let me just leave this if I want that. Okay, so right now I cannot see what I have just now right now. Okay, so right now I can see what I have just now right now. So right now the first thing to do again is now click on this place rectangle and then form something like a block around this region, and then click on this right now, type TR. TR means trim, and then trim, just hover this place and trim off this and trim off this and click here and click on this place and click on this place. You can see what now? Then now click on this and remove this right now immediately and delete this. Enter. Okay, so you cannot see what I've done right now. So right now we have all created all our grid lines. So this is now our structural grid lines. You can see it right now. So we are not following the grid lines that was created by the design architect, the person that drew this plan. So we have created our own structural grid line. So this is the grid line that they will follow during the construction to set out this building at site during the construction. So right now we have created all our grid lines right now. So let's need to do right now is now begin to place our column points. So right now I'll click on this place right now and then click on to activate my column grid, my column layer. So right now, to create my column right now, I always say you should use this place called rectangle. So don't use a line like this to create your column. It will not work. Sorry. Don't use a line like this to create your column. It will not work because Protastructure, we're not going to see it as column. Don't use a line to create like this as column. Else, it will not work. It will never work. So I always say you should use what they call rectangle or rec. Or you can see it here also. Click on this and then create your column. So I'll say rec right now as a shortcut for rectangle icon. I'll just say rec and I'll click on enter. I want my default column size to be 225 millimeter by 2 millimeter. So I'll just go right now and click my column size and click. So let me just recap. If I do rec right now, enter, I'll click at the point here and type my column width, which is 225 as my default column width. I'll press comma for the enter. You can see that comma. I'll type 225 again and I'll press on enter. Now, if you didn't get what I just did right now, you can also use a polyline. I can see it here, polyline, and also create this column. So I just click right now and type 225, enter. I'll go a 225, enter, and 225, enter, and then 225, enter, and then escape. So you can see that they have the same type of thing. So right now you can use any of them if you want to use any of them. So let me just use this one right now. So right now, since I've done this right now, I'll now have to start pasting this column at the midpoint at the place where I want to position my columns. Okay, so right now, just copy this right now. CP or CO, enter, that's copy, and locate the center of this wall of this column. As you can see it here. So just hover your mouse button around the edge, and immediately you see this, you will see the point here. Now, if you are using AutoCAD 27, you're not going to see this. So what I'll do, if you want to get your point right now, just say you should just hover. You should just create something like this. Let me just use this. create something like this to form like a diagonal for you to locate your point, if you're using a older version of AutoCAD, and then just copy just the column from this center point right now and begin to place at the midpoint of at the place where you want to place your column. Now, placing of column as a structural engineer depends solely on you. You have to make your point on where you want to position your columns. So nobody can tell you what to do on this area. So that is why you need the knowledge of position of column. And the only thing I'll tell you is that when you're positioning your column, the column spacing as a fresh engineer or as a beginner in the design world, I would say that you should make sure that your column distance as a beginner structural or civil engineer should not be more than 6 meters. What I mean is that if you put a column here right now, as I put right now, and then put again here, if I measure this distance from here to here, let me just measure the distance right now from let me just activate my dimension because it's as if it is not set to the dimension is not showing. Let me just set the dimension right now so that it can be visible. Let me just choose text height to be 200. Okay, let me just do a default text height right now and then set current and then just close. If I do right now dimension, so what I mean right now, if you measure this to this right now, it should be at least less than 6 meters. So this right, let me do again. That's not showing me a good dimension line well. Let me just set a good dimension, just a default one right now, so that it can be okay. Come here, position, and just say position 0, and then come here right now, and then fit here, and then just use this right now, and then just say okay, and then set current, and then okay. Okay. So right now, what I mean is that as a fresh engineer, your column distance as a beginner in Protastructure or any kind of design software should be less than 6 meters first. It is when you have gotten enough knowledge, as you can see right now that this is 4.45. So the whole building length right now is 4.45. But if you check on this area right now, if I check here right now from this column to this column right now, you can see that this is 5.5. So as I'll say that for a beginner in the design industry or in the design world as a structural or civil engineer, make sure that your column distance for a residential building is less than 6 meters, at least 6 meters as maximum. But when you are strong in the design world, you cannot begin to go up to 8 meters, 10 meters. Like for me right now, as a I have over 10 years experience in the civil and also in the civil and also structural design industry. I have designed a column to column placement of up to 15 meters, up to 8 meters, 10 meters. I've done that, 12 meters. I've done that also. So you can see that when you are strong enough, when you have confidence in yourself, then I'll say that you should now begin to um go further. But for now, as a beginner, you have to maintain 6 meters because you going further to around 10 meters, 12 meters, there are some things you're meant to understand. But for now, if I tell you that right now, you'll be confused. So right now, you just have to maintain your clone to clone distance to be 6 meters right now for now. So this is 4.5. So this is okay. So right now I'll go right now and then begin to place my column points. So right now, since I've placed here right now, I'll also go right now to place this also. I place this also at this place right now. Place this at this point right now, and then go right now and place this here also, and place this here also, place at the midpoint of this place. Okay, and then come here right now, place this here right now, place this here, and also place this here just now. Okay, and then place this here just now, and then also place this here just now. Okay, and then place this here also, and then come now and place this here. Okay, so once you're done placing all your column points, then you will now begin to check what they call column distance rule. Like I said, it should not be more than 6 meters. So if I measure from here to here right now to check this distance of column, you can see that this is 5.5. So this is okay. There's no need to place another column at the midpoint here. Since it is less than 6 meters, I'll check again from here to here also. This is okay, 5.5, which is less than 6 meters. I'll check again from here to here, which is still okay, 5.5. That's okay for me. And I'll go again and check from this to this to the staircase area, 2.2. That's far away, okay. And I'll check this again from this to this. This is okay, 5.5. That's okay. I'll also now check, since I have uniform vertical distance, I'll just check one of them. Check from this to this. You can see that I have 4.5. So this is okay, perfectly okay right now for me. So you can see that With this right now, I can choose to use here right now as one panel. You can see that. So I can, if I'm using here right now as one panel for a slab, that means I will not have to remove this right now. So this is where it comes to play to make your plan different from the architecture. This is now what they call a structural plan, because this is where your slab now will be. So right now, I'll also remove this also. Take this off right now and take this off right now. I can now go right now and now call here what they call panel one. Panel simply means where your slab is going to stay, where you have to put your slab. So you can see that I can now put this place as a panel. And also as panel one, sorry, I'll just say, let me just say P1 as a simple language, P1, which is panel one. So also when you're following your slab panel, I would say that there is a rule to obey in your slab paneling. For you to call this place like something like for you to call a panel, like one panel, the the square area should be less than 30 meter square area. What I mean by that is that if you measure the length of the panel, you can see there 5.5, and the width of the panel, as you can see it here, this is 4.5. If you multiply this together right now, it should be less than it should be less than 30 meter square area. So if we times this right now, let me say calculator right now, QC, and then enter. If we times this right now, this is 5.55 meters. So 5.55 multiplied by 4.45. So 4.45. So if we do equals to right now, this is 24.69. You can see there, approximately 24.7. So this is less than 30 meter square area. So by this rule right now, I can call here panel one. So your panel or your bay must be less than 30 meter square area. Else, now let me tell you, because this is like a discussion class, because if I believe you have watched most of my videos, and by now you you can design very well perfectly using Protastructure. Now, this is not time to teach you, like I said before, here on Ekidel, we have to train you very well like a full civil and structural engineer for all beginners. So right now, what happens is that if your area of panel, as you can see right now, we just did right now, this one gave us 24.7 meter square area. So if your area of bail is more than 30 meter square area, which was given to us by the British Code of Practice and also by the Indian Code IS standard, that your area, which if you're following Euro code, British code, and also American code, that your area of a panel for concrete building must not be more than 30 meter square area. Now, if what the now the effect you have if your area of a panel is more than 30 meter square area, what happens? I don't know if you have been in a building before, like a one-story building or a building where you have a decking, let me say like a slab on top. Let me say you have a slab. Let me say this is a slab, right? Let me just use that. This is a slab right now. This is a slab right now. And there is somebody here, right? There is someone. Let me just use this weight right now. There is someone. Let me say someone staying at the top of this of the let me say upper floor. Let me say someone upper floor right now. This let me say this is somebody right now. This is someone right now upper floor. Let me just draw someone with just something like this, and also having a two hands here. So this is, and then this slab thickness. Let me say this slab thickness right now is 150 millimeter. If this slab, okay, let me just, yeah. So right now, as a slab thickness, this is now a slab, and this is, let me say, this is now a slab, and this is also the slab end here. And this person right now, let me say, is somebody that just rented this house right now, which is staying upper floor right now. Now, you are the one now staying down floor here. You are the one staying at the down floor at this place right now. Now, if this person, if the now the effect you have, if this, let me say this is a slab, let me just change it to like white to white. Okay. Now this is a slab. Now the effect you have if the area of a panel is more than 30 meters square area, let me say 31 or 32. Now, if it is slight more than 30 meters square area, what happens is that if this person staying up here, let me say is at the kitchen, and mistakenly a plate falls from his hand and falls from his hand, or a cup falls from his hand right now and falls on this slab decking, you and falls on this slab decking on this slab decking right now, we all know that there will be a sound on this other side. Now, what happens is that if this panel is 130 square area, this slab thickness or this slab will not be able to withstand that sound. It will allow that vibration to pass through. So it happens that you, which is at the ground floor of that building right now, you now begin to hear sound. You also be able to hear the sound, which automatically, if this panel was less than 30 meters square area, you won't be able to hear the sound. But because you have gone across that rule, since the slab will not fail because you are still within that 30 meter square area, or you are a bit higher than that, what will happen is that there will be what they call porosity on the slab. Now, sound will be able to pass through the slab, and you that is staying downstairs or at the ground floor will be able to hear the sound of the person that made the sound at the upper floor. So that shows that that slab is one. There are two things that causes that sound for that causes that effect for you to hear that sound at the ground floor. Why someone at this first floor made a sound, and you're able to hear it at the ground floor. There are two reasons. One, either that panel is more than 30 meter square area. That's one reason. Two, it's either when you're performing your slab reference spacing during the construction, they 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 like they didn't follow your your slab prescription. What I mean by your slab prescription is that if you specify that the spacing of reinforcement should be 150 millimeter each, and they now went ahead and give 300 spacing each, what happens is that there will be a vibration pathway through. So if someone at this first floor throws, let me say, throws a cup or a plate on the decking, you on the downstairs will be able to hear that vibration, or to hear that sound, of which it's not meant to be so. So that is the kind of effect you have if that slab didn't sag, or if that slab didn't deflect, you'll be able to hear that sound. But if it is far, let me say you're up to 40 meters square area, that slab, there will be a deflection on that slab. So to be able to control that slab, you have to provide what they call internal beam, or a concealed beam, to be able to cut that panel into two. So right now, since you already know what I'm doing right now, so this place also, I'll also remove this place and make this place as one panel, because it's already less than 30 square area. Because if I measure it right now, I can see that this the width of this place is 5.5, which 5.5, and this width of this place right now, here to here, is around 4.5, as you can see it here, 4.45. So if I times right now, I'll get 24.7 meter square area, which is less than 30 meter square area. So I'll call here right now panel 2. So this is where my slab will be also. I'll call here panel 2 right now. And then right now, I'll go here right now again, remove this place, and call here panel 3 to form a panel here. I don't want all this. And call here panel 3. You can see how we are doing what they call structural framing right now. Structural framing, this is what they call GA drawing, which is called general arrangement drawing. So this is now panel 3 right now. Then I'll also go here right now, remove this right now, remove this also, remove this also, remove this also, and then remove this also. Then go here and then try to join this place, because I want to make here as one panel, this small one, make here as one panel, join from here to here. Okay, then remove all this here. So this is now a beam right now. So I'll call here again right now panel 4. I'll call here panel 4, panel 4. Okay, 4. And then here, which you have a staircase, is always a void. So I'll just use a void symbol. I'll use a void symbol. I'll just create a void just here. This is a symbol of void. This is a symbol of void for a civil and also a structural engineer. You have this as a symbol of void. So this is a symbol of void. So I'll just use this right now, create a symbol of void. Then I can just go right now and remove this staircase symbol, because this is not what I'm talking about right now, because we will use this when we enter the structural detailing. But for now, this is just, we are trying to form our plan for the design. So I'll take off this also and take off this also. Okay, and then try to form a beam around this area. So this should be a straight beam. This should be a straight beam. From here to here should be a beam, and from here to here also should be a beam. Okay, so you can now see right now. So I have panel 1, 2, 3, and I'll also come here right now again, remove this also to form here like a panel, and also remove this also form here like a panel right now. And then this also should be one panel, one panel, and remove this also. Then try to form a straight beam here, and also using join to join this one. Okay, to do this right now. So you can now see if I'll now copy here right now, copy this right now to put this and put this. This will now be panel 5. This panel 5, and this is panel 6. So you can now see how we have successfully panel 6 created our structural framing. So I'll take off this right now. So you can now see that this is what they call architectural plan. You can see how it is, and this is what they call a structural plan. So this is your structural framing. So this is now what we will now export to Protastructure. This is what we will export to Protastructure. So if I check this also, let me check from this to this point. I have 5.5. Okay, no need to put column here because it is less than 6 meter. So you can now see that this is my panel 1, panel 2, panel 3, panel 4, panel 5, and panel 6. So you can now see how we have streamlined all these box to panel 6. So we have ordinarily we have one panel, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can now see with the knowledge of structural engineer and and with the principle of this column spacing and the paneling, we have now made just this building to have how many panel slab? 1, 2, 3, 4, 5, and 6. So you can now see that. So in my next video right now, I will have to do a superimpose where I'll have to copy this plan and put copy this column and put it into this place to see if there's any cantilever, and if there's cantilever, we'll now consider it before we can now export to Protastructure to begin our full structural design for this structure. Like I said before, this is a live project and we will be designing this building all the way through our Protastructure, and we'll perform a full structural detailing where we'll show our bottom bar and also top bar for the slab detailing, and I'll also show you how to bring out your all your details from Protastructure, and we will paste it on what they call stone bridge structural detailing templates, and we'll also show you how to detail your staircase manually also. But before this time, before we be done with this building, Stonebridge Company have already produced the software for staircase detailing, of which I don't know the price yet for now because they have not yet fixed the price. But we are still asking them to facilitate it so that we can be able to do a video on it because we have already used it, but we cannot show you guys right now because we are like a partnership with them Stonebridge, so we don't um, just use their software until we have a full permission for it. So we are already at the line of getting the full permission, then also then sending us the the link for we to now start selling the software and also teaching how to use the software. So right now you can see that we have successfully created our what they call structural framing or general alignment drawing, what we call GA drawing. So in my next video right now, I have to check if this two if the first floor plan and the ground floor plan, if they are the same or typical. If they are not, but I believe there should be a cantilever at this area, so I'll check if there's cantilever. If the cantilever, then we will have to now check it out, then before we can now begin to export this plan right now to put a structure. So I'll say that if you have not clicked on the subscribe button, I'll say you should click on the subscribe button so that you don't miss all our coming videos. And also, I will say also that the reason why you need to subscribe is because if you check on our previous video, we have not done much video on when the both plans are different. Although we may have done, but I don't think if we have explained this kind of thing before that we explained here. So that's why you need to subscribe, because this we are here on this Ekidel to train you guys a lot on how to perform your full structural detailing. And also, if you look at this place, also we also have um is we also have a classroom block design which you are about to perform. Also, you can see it here, and also we have also gotten someone that will be training you guys on how to draw floor plans and also how to create your floor plans and also elevation. That will be for let me say for the people studying for the people studying architecture. Also show you how to cut sections. You can see how they cut sections, and also show you many things about how to draw plans, a full functioning plan. You can see the staircase and all that. They will also show you how to do all this. And then also for your window and door schedule, they will also show you that. And then also we also will be running on how to I also should showing you how to create all this. Also, you can see that we have a lot of projects. You can see that this is a first floor. I know most of you guys don't know what they call first floor, but just not to confuse you, let us go over what we have for the day for the weekend, which is to design for this structure. So okay, so we have come to the end of the day, and before we go, I'll have to hail all my guys from Ghana. You guys are doing marvelously great by sharing my videos, and also telling your friends to come and subscribe and watch what we are doing right here on Ekidel. Also, I want to thank my friend all the way from Kenya. Also, my friends from India, Nigeria, and also my friends from Uganda. You guys are doing great. Also, I have some friends from Dubai. We are saying thank you guys for you guys are doing wonderfully great from sharing our videos and also calling to all young engineers to come and also benefit what they're doing here. So thank you so much. I'm very grateful to you guys, and I still remain your instructor, Justice Mwakana. I love you guys. Now, if you have any comments concerning or any question, or you're having issues concerning what we are doing right here, I would say you should just drop your comment down below. And also to make it more easier, because we are committed to train all civil and structural engineer. We have also dropped our WhatsApp number so that you can reach us out you can reach us out on WhatsApp, either on video call or on voice call or through chat, and we'll explain to you and teach you more on where you're having confusion on the structural analysis or design, or in the way of your civil engineering career or structural engineering career. So thank you so much. We have come to the end of today's lesson. So thank you so much, and God bless you all.